Hi guys, so what I'm going to do is I'm going to walk you through the information you can read from a chemical formula by identifying the number of molecules, compounds, or atoms each formula is presented. So the first problem we have here is CO2, which is carbon dioxide. So we're looking at the total number of CO2 molecules. Now since there is no coefficient or number in front of the molecule and compound, we assume that it's a 1 because it's still written down, CO2. There's just no other number there to indicate there are more molecules present. So there's no coefficient, so you assume it's 1. The number of carbon atoms. Well, all we have is the symbol C with no subscript. So you assume that it is 1 atom. The oxygen, which is here, the O, for the symbol, has a subscript 2 behind it. That 2 goes only to the oxygen, so it tells us that we have 2 oxygen atoms. In addition, it wants to know how many O2 molecules are present within the carbon dioxide compound. In this case, we are only looking at the O2 as a whole. So we're looking at O2 as a molecule, as a component compared to the compound CO2. So in this case, we only have one O2 molecule. Now let's have a look over here. We've got C6H12O6. Again, that's a very familiar compound that you should know by now, which is glucose. So it wants to know how many molecules are present for the glucose, C6H12O6. And since, again, there is no coefficient, you assume it's 1 because their molecule is still written out. Now, the number of carbon atoms present. We have our carbon symbol. Here is the subscript. So in this case, we have 6 carbon atoms. Number of hydrogen atoms present. So here's our hydrogen. Here's the subscript that follows. So we have 12 hydrogen atoms. And then lastly, it wants to know how many oxygen atoms are present. So we have our subscript right behind the oxygen. So we have 6 oxygen atoms present. Now, an additional question I could ask you is how many total atoms are present within the molecule or compound. In this case, you would add up the subscripts, 6 plus 12 plus 6. In this case, we have 24 atoms total that make up the entire compound. Let's have a look down below. Okay, here we have 18H2O. Notice we have a coefficient now. That coefficient means that we have 18 hydrogen and oxygen compounds together, 18 water molecules. That means that our number here, 18, that coefficient, is the equivalent of writing H2O 18 times. But like I said, who wants to do that? That's pretty tedious. My hand's already getting tired filling all of this up right now. And I'm not even maybe halfway there. So this is pretty tedious. So this is why scientists use the coefficients to make things easier. Just like students, you want the easy way out, so do chemists. So the 18 means that you have 18 of these molecules present. Now here's where things get interesting. How many atoms are present? You're going to look at the subscript. That subscript goes to the hydrogen. But here's the thing, we don't have one hydrogen, one H2O molecule, we have 18 of them. So we're going to have to take that 2 and multiply it by the coefficient 18. So our hydrogen atom is really 2 times 18, or 36 atoms total. Okay? Similar, our oxygen in our water molecule doesn't have any subscript. So you assume it's 1 because it's still written down there. So in this case, we take 1 times 18, and that will give us 18 atoms of oxygen. And lastly, it wants to know how many molecules of hydrogen do we have as a whole. So here is our hydrogen molecule. Notice the subscript. This plays an important role. So in this case, we have 18 hydrogen molecules. It's like I said, I wrote all of these down 18 times. That's what that coefficient represents. Now let's look at our last problem here. We have a coefficient of 2, C8H18. So in this case, that 2 means that I have 2 of these written down. So that, again, that's the equivalent of writing C8H18 twice. But like I said, who wants to do that when you can just put the coefficient? Now, how many atoms of carbon are present? So here's our carbon. Here's the subscript. So I'm going to take the subscript and multiply it by the coefficient. So I'm going to take 8 times 2, and that tells me I have 16 carbon atoms. The same way I'm going to apply for the hydrogen. The hydrogen has a subscript of 18. So I'm going to take that 18, multiply it by the coefficient. 18 times 2 equals 36. So I have 36 atoms of hydrogen. What I'd like you to do now is to do the next backside here. It's a little blurry. There we go. So what I'd like you to do is to do the backside on your own and have it double checked with the sub. What I would recommend you do for this part B section is I would recommend you do your phosphorus equals number of atoms and your oxygen equals number of atoms. That way it's easier to read and identify. I guess I can do a quick problem just to double check. It never hurts, okay? So phosphorus has a subscript of 4. Okay, so I'm going to take the coefficient, multiply it by the subscript, so it's going to give me 16 atoms of phosphorus. And again, the oxygen now has a subscript of 10. So I'm going to take that coefficient, distribute that to the oxygen, and now I have 40 atoms of oxygen. Okay? Well, I would like you to do this, have it double checked with the sub to make sure we're all squared away, and then I will see you guys later.